Hello, everyone. My name is Sarah Roákopf, and I have the pleasure to share with you some insights on the impact of visual virtual scene and localization tasks on auditory distance perception in VR. I am a clinical psychologist and psychotherapist, and this work is part of an interdisciplinary project called Auditory, which combines acoustic, psychology, and virtual reality research. Now to the background of my research questions. Creating immersive virtual scenes with a high level of presence is, of course, a major goal of VR research. Also in virtual acoustics, a high effort was made in recent years to synthesize spatialized three-dimensional sound that is highly realistic and natural. Nowadays, hearing impressions can be synthesized that are indistinguishable from real sound sources, indicating a high level of immersion. However, when acoustic and visual scene do not match, the quality is lowered. This presents a significant challenge for audiovisual virtual environments due to the specific visual spatial perception in VR. Compared to the real-world equivalent, a virtual scene that is presented via a head-mounted display appears up to a quarter smaller to users, meaning that the egocentric distances are compressed. Also, it is known that multimodal integration is prone to visual dominance over the auditory system. For example, a well-known phenomenon is the proximity image effect, which means that the acoustic distance estimation is shifted towards the visual object. These findings indicate that auditory distance perception may be altered when using an HMD. And indeed, in two VR studies using an HMD, an overestimation of auditory distances was found. This is in contrast to typical findings from psychoacoustics that sound distances are rather underestimated. Note that in these experiments, the positions of physical sound sources had to be specified within the visual virtual scene, indicating a possible interplay of acoustic and compressed visual scene. The main goals of this study here now was to investigate the effects of audiovisual incongruency on sound distance perception in VR, as well as more generally the effects of visual distance compression. Furthermore, we wanted to explore the interplay of audiovisual scene and task. We investigated these questions with two sequentially conducted pre-registered experiments. In the first experiment, the focus was on the investigation of audiovisual room incongruence. The results motivated a further study, which more generally investigated the effects of visual scene on the one hand and the influence of the measurement method itself on the other hand. To begin with, experiment 1. We manipulated whether the displayed room model was congruent or incongruent to the physical room. Participants had to localize real sound sources emanated from real loudspeakers in the room by placing a virtual agent at the estimated source position via the HTC Vive motion controller. To the results. This figure depicts all relevant positions of participants during the course of the experiment, positions of the real sound sources in those squares here, and in the corresponding color, the estimated positions. On the left side, you can see the trials from the congruent room condition, where the walls of the acoustic, the physical room, and the displayed visual room were the same. And here you can see where that the physical room is, of course, the same, but the visually displayed room is enlarged. And you can see that in the incongruent condition, the deviances are greater and more front-back confusions occur. Confirming our hypothesis, we found a significant detrimental effect of audiovisual room incongruence on localization accuracy. Furthermore, you can see that in both conditions, sound distances were overestimated as found before. We also let the participants rate their levels of present and realism of the scene during the VR experience via motion controller and visual analog rating scale. Contrasting our hypothesis, we found no effect of audiovisual room incongruence on ratings of presence or realism of the scene. As again, a constant overestimation of sound distances was found in experiment 1, we wanted to shed a light on the role of the measurement task, and especially this placement task, which needs a high amount of multimodal integration. And also the interplay with the room visibility, which were both manipulated within the second experiment. Either an audiovisual congruent room or a scene containing almost no spatial information was displayed. Additionally, 3 different methods to measure sound source to measure perceived sound source distance were used. Participants indicated distances either by placing a virtual loudspeaker, walking, or verbal report. In the placement task, participants were instructed to place a virtual visual loudspeaker at the perceived distance of a sound source via the HTC motion controller, comparable to experiment 1. This is how it looked in the visible room condition. And that is how it looked in a blind condition. In the walking task, participants are instructed to walk to the position at which the distance of the sound source was perceived, and then confirm this position via a button press. This is how it looked in the visible room. And here how it looked in the blind condition. In the verbal report task, participants were instructed to simply speak aloud their estimation of sound source distance. This is what we found. The measurement method significantly influenced indicated sound source distance. And this effect was modulated by room visibility. Overestimation of source distances was significantly higher for the placement task in comparison to walking and verbal task. And while this effect was pronounced in the blind room condition for the placement task, the reverse direction was found during walking. A possible reason for the higher overestimation found for the placement task is that this task needs the highest amounts of cross-modal integration. Cross-modal integration is also needed in the walking task, but here further cues from body movement and proprioception could have compensated for visual compression. The verbal method theoretically doesn't make use of the visual system at all. For a more in-depth discussion of these results, you may have a look at our paper. To wrap up, it definitely does matter what you display when a virtual scene is processed also auditorily. And you have to consider the effects of the task with which you measure these effects. Furthermore, presence was affected by the used task, but not by scene visibility or audiovisual incongruence. To conclude, for several fields of application, the special features of visual virtual scenes should be considered. The interplay may be relevant in perception-related psychoacoustic experiments in mixed reality environments. Also, in the context of digital twins, for instance used for architectural applications, the exact room acoustical features and dimensions should be incorporated. Finally, further research is needed on multimodal integration in VR, for example, to clarify appropriate degrees of visual or acoustic adjustments to create a smooth audiovisual scene. Thank you all for listening and thank you for your attention.